Hey there, stargazers, and welcome to the Daily Space Weather Show. We've got some spectacular imagery for you, as you may have come to expect from the channel, so thanks for tuning in. Thanks for stargazing here at the Smash News Network, least busted name of news. We're looking at the sun here for the past 24 hours. That's the SDO, Solar Dynamics Observatory. And let's take a quick look. What's that? You want close-ups? You want close-ups of the sun? You want to stare into the sun? All right. So the most likely place to see a large solar flare remains the northwestern limb. There is a setting sunspot group up there. We'll look at the magnetic complexity of that in great detail before we get to our meteorology segment. There's a great detail of it in 171 angstroms. You can see some plasma instability happening there, and that is one of the features that you can expect probably preceding solar flares. Many of us believe that coronal mass ejections cause the flares and not vice versa. A lot of people seem to think that solar flares cause coronal mass ejections. And in physics, chicken and egg arguments do matter. There is an active region there setting in the southwest as well. Meanwhile, we've got some significant sunspot groups over here in the southeast. Great view of that in that same great SDO wavelength. That's, by the way, extreme ultraviolet light. Not visible from the ground. That's why we use spacecraft like the SDO. Also, the SOHO features 171 angstroms. The SOHO a little bit farther away from Earth. It's located at Lagrangian point 1. The SDO is in a high Earth orbit. So there is the full disk equatorial zoom. And that, my friends, is pretty sweet. Next, we're going to show the imagery from yesterday and today, the SDO continuum. And it looks like not a lot of changes happening here. Actually, one sunspot degraded. That one looks like it's evaporating entirely. But besides that, not a lot really happening in terms of sunspot evolution. Oh, a little degradation happening up here as well. But there is still a high likelihood of large flares up here, as the deltas were appearing on the trailing edges of these sunspot groups. Here is SDO colorized magnetogram, the same period, that is August 19th and August 20th to date. Let's turn around and look at Earth here for a moment. Here's the volcano rundown. It looks like a lull in volcanic activity. Subanose Jima is erupting, though. It's producing a 6,000-foot ash plume. Bagana is exploding, producing a 10,000-foot ash plume, flight level 100. Popocatépetl exploding, flight level 200. It's a 20,000-foot ash plume over central Mexico. Fuego exploding in Guatemala, flight level 160, 16,000-foot ash plume. Not sure about Sangay, but volcanic ash emissions are possible. And Sabancaya is exploding, producing a 22,000-foot plume of volcanic ash. Please do not pole vault, hang glide, or broad jump the caldera. No track events over the caldera, please, folks. Next, looking at global seismicity, we'll call out quakes of a 5 or greater magnitude. It's been a low activity as far as large quakes, but a bunch of quakes on the west coast of the U.S. Check it out. Just not big ones. Also, one up there by Yellowstone will have people thinking that a supervolcano is going to erupt. I would tend to disagree. Anyway, here are the quakes of a 5 or greater magnitude for the past 24 hours. First, a China quake, a quake from China. A China quake. It's probably made with stolen intellectual capital from the United States of America. Okay. That's a 5.0 in Zhejiang at 14:46 Universal Time yesterday afternoon. About 22 hours ago. 22 hours from when we produced this video. There was also a 5.4 near the northern Mariana Islands. Did you know that we did some calculations on Twitter to calculate how much marinara sauce would fit in the Marianas Trench? The Mariana Trench, if the Pacific Ocean was drained of water? Yeah, that's a thing. It only holds about 9 million mozzarella sticks worth of marinara sauce. That 5.4 at the Mariana Islands was at 23:10 Universal Time yesterday evening. There was also a 5.2 in the Aleutians there. That was at 1:48 Universal Time this morning. And that is it. Only those 5+ magnitude quakes over the past 24 hours. Now let's get back to space here. The 10.7 centimeter radio flux is still at 151 solar flux units. And let's take a look at, there's SDO 193 angstroms, another 24-hour video. And let's get to our space weather stats here. So again, the radio flux, 151 solar flux units. There's the 1-year graph. The black line is the radio flux. The red line is the sunspot number. They are proportional. In other words, when we have a high radio flux, we have a high sunspot number, and vice versa. Space Weather Enthusiast dashboard here. This is NOAA's forecast. Not forecasting any geomagnetic unrest or geomagnetic storm conditions. A quick note that we have a very high elevated solar wind speed here. So there's a coronal hole high-speed stream happening here at the moment. 624 kilometers per second there, as shown on the Space Weather Enthusiast dashboard. That is a significantly fast solar wind. And if the magnetic fields shift, we could see that go right into geomagnetic storm conditions. So be prepared for that. Just a shift in the vertical component of the magnetic field could cause KP5 or greater with that level of solar wind speed. Here's Earth's magnetic moment from space for the past 4 hours. It's the Geospace Magnetosphere movie. And things are pretty chill out there because at the moment we've got a positive vertical component to the magnetic field, which creates more of a push than a pull. It doesn't really induce a lot of electrical current into the earthly system. Again, that's the past 4 hours of magnetohydrodynamic pressure, Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. And yeah, it's, again, geomagnetically calm conditions. This map, if you're new to the channel, it will show you the most likely places to see the aurora. Also, pipeline, railway, and power grid induction are the most likely, where you see a large change in Earth's B field there, geospace delta B. That's in nanotesla magnetic flux density. Moving on to the KP index, which is currently at 2.66. Again, you could see this come all the way up here without an even strengthening of the magnetic field. You'd see a geomagnetic storm condition just because of a major shift in the BZ. So let's go to that next. Here's the solar wind data. And a quick reminder that it is measured at Lagrangian point 1. So those spacecraft, like the SOHO, the ACE and Discover, they're located about 1 million miles away from the Earth there at Lagrangian point 1. So here is our solar wind data. Current conditions are very diffuse, so only about 1 proton per cubic centimeter there. However, also very fast at 604 kilometers per second. And when we're talking about the BZ, we're talking about this pane up here. So if this red line shifts way down to the negative, let's see, what is the field strength? So if we had a 7 and a -7 there, we would probably go into at least geomagnetic unrest conditions, maybe like a KP 4.33 or something like that, because of that elevated solar wind speed. It's also accompanied by an increase in the plasma temperature. So not a big spike in the density here, but a big increase in the solar wind speed. So that's another characteristic of a coronal hole high-speed stream. 624 kilometers per second there for the solar wind speed, a quite elevated solar wind speed indeed. And there are the GOES magnetometers. No big spikes in those because, once again, the density wave on this coronal hole high-speed stream was very modest. So fast material there coming out of the sun, just not dense material coming out of the sun. That's the past 3 days as measured by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. Next, we'll look at the top view ecliptic plane field plot. And let's see, is the Earth in a South Pole current sheet yet? No, it looks like it is not. So check it out. There you go. Earth still in a North Pole current sheet here. And in the next few hours, by the end of the day today at least, Earth should snap into this South Pole current sheet. So keep in mind the magnetic environment can change with basically no warning. If you're getting any warning, it's probably from our channel. Congratulations on realizing it exists. Here's our line of sight field plot depicting the solar B field in blue, polar fields in green for north and red for south. Also, the grayscale portion depicts the photosphere gong magnetogram. And you can see a lot of magnetic organization on the Earth-facing portion of the solar disk. Since there are hundreds of sunspots there, it's something that you could come to expect. So let's move to coronal holes next, as they are super crucial for the solar sunspot cycle. Did you know that at solar minimum, the polar fields, they just hang out at the poles? And as the cycle progresses, they flip. Yeah, so if you're spooked of a pole flip, every 11 years a pole flip happens on the sun. And it doesn't cause any disasters. There's no 11-year disaster cycle. There's no 11-year hurricane cycle. So just get that nonsense out of your head entirely, because these are separate systems. So that's the coronal hole situation. We do have these rather well-defined coronal holes down here, right in the Earth-facing zone here. Those are North Pole orientation. And then up here we have a U-shaped series of South Pole coronal holes. Let's take a look at that from SDO. So there is the 211 angstroms wavelength, and this is an interesting setup here. These are North Pole, and then there's like a sector boundary crossing like this, and all of these are South Pole. So that is a kind of a unique setup there. North and South Pole coronal holes here currently oriented toward the Earth. And this might cause an intensification here as well in about, let's see, sometime late in the day, Tuesday, we might see a density spike. It might be a short-lived coronal hole high-speed stream there if we do see one from that. Again, sometime around like Tuesday, may see some changes there in the solar wind parameters based on that North Pole-oriented coronal hole in the southern hemisphere. So again, there's a still image from the National Solar Observatory, the line-of-sight coronal hole plot, and let's move to sunspots. So there's a sunspot situation. Again, no major changes here. One of these sunspots did degrade. 3404 is now barely a sunspot still. This group down here is barely a sunspot also. I looked at a high-res image of that earlier this morning. Yeah, so besides that, no major changes. Let's take a look at it from SDO Continuum. So there's another 24-hour video, approximately 24 hours. And up there by the Earth scale is still the most likely place to see a large solar flare, in my opinion, especially back here on those trailing umbrae. That is where the most magnetic field complexity is currently happening, the most magnetic shear. And if you're wondering if solar flares are predictable, they're absolutely predictable. It's just a matter of closely monitoring the magnetic shear characteristics of those opposite polarity umbrae. Next, SEPs, solar energetic particle events. We don't have any. Things are calm on the GOES proton front. No spikes, but if we do see a major flare, it might be accompanied by a proton flux. An SEP, a solar energetic particle event. At the moment, the GOES 16 not measuring any of those. And here is the X-ray situation. Interestingly enough, we saw the largest flare in the past 24 hours happened at almost the same time of day here. So yesterday morning it happened at about 6:40 Universal Time. Today that happened at about 6:20 Universal Time. So that's pretty interesting. And we did have another flare here happening while we produced the video. So there's the sun chiming in once again, probably endorsing the channel. I would watch this channel if I were the sun. What about you? Let's take a look at X-rays here, or it's still ultraviolet light, but there's the past 24 hours in 94 angstroms from SDO, and that most recent C-class flare came from this group down here, actually. So again, the western limb is going to be the most likely place to see large solar flares. There is another active group rising in the east as well. So, I see a flare coming from there also. So anyway, that's another 24-hour SDO video. Let's also check it out in 131 angstroms. And the reason that we use 94 and 131 angstroms from SDO to view solar flares is not because they're actually viewing the X-ray spectra. It's still the UV spectra, extreme ultraviolet light. The reason we use 94 and 131 angstroms to view the solar flare activity is because of, first of all, the chemical species that they represent, but also because they have a higher temporal resolution than the other wavelengths from SDO. They take 10 images per minute instead of 2 images per minute, something like that, like 5 times as many images, and so you can get a lot higher temporal resolution and see those flares play out with a lot more detail. That most recent flare peaked out at about a C2.5. Moving right along to a star chart, this is what's going on overhead in Lehigh Valley, Pennsylvania. We've got Mercury and Mars just rising here over the horizon behind the sun, not visible because it's light out, and Venus has recently become a morning celestial body. Jupiter high in the ecliptic there. Saturn has set a few hours ago. That star chart from skyandtelescope.org. Here's a solar system forecast. Here's where things are today. Let's move this ahead 1 week. Here's where things will be in a week. And let's talk about classifying galaxies. Have you been to zooniverse.org? Check it out. It's the largest citizen science project in the world. Zooniverse.org, folks. We've also got the Hemp Lucid shop, and stress mushroom gummies are today's featured product from Hemp Lucid. These will not make you drowsy, by the way. They might take the edge off of stress, so perhaps check those out. Also, the Focus mushroom gummies are a good call. I take those regularly as well, so maybe check those out. And you can find links on our homepage at smashomash.com. Today's featured merch item is 30% off. 30% off the entire Redbubble shop. So if you're thinking about picking up merch, now's a good time to do it. Today's featured product is the Croissant Earth Society. Yeah, so we like to have some fun on the channel. And I like to make my memes into products that you can buy. So when will you stop believing NASA's lies and realize the truth that Earth is not shaped like a pizza, with Antarctica being the crust? It's not shaped like an oblate spheroid at all. It's shaped like the French breakfast pastry. When will you stop believing NASA's lies? Aren't you familiar with Operation Paperclip? Yes, everybody knows about Operation Paperclip. I'm so sick of hearing about it. So maybe join the Croissant Earth Society and go tell your friends and foes about it. Tell them to stop believing NASA's lies. And of course, this highlights my extremely biting, sarcastic sense of humor. And again, you can find links on the homepage at smashomash.com. So visit us over there. You can find all kinds of links to our social media accounts, etc. Hashtag name that filament over on Twitter. Welcome to the Neo-Renaissance. We released information last night about a laboratory experiment. So we've been explaining the solar sunspot cycles to our Gold Smash Team members. It'll cost you $9.99 to hear about the actual plausible mechanism likely underlying the solar sunspot cycles. And I had a eureka moment last night. I figured out a cheap laboratory experiment that can be used to simulate the sun. Yeah, a cheap laboratory experiment used to simulate the sun. And we'll be building one of these things soon, thanks to Gold and Silver Smash Team members especially, for increasing the probability these videos will remain existent, free for all to view, and public. Yeah, public. Again, smashomash.com/smashteam. It's our custom subscription services site. The best value is the Gold annual paid-up subscription, as it includes complimentary merch. Now, you may have seen our community post last night. We're being a little bit critical of talc here from Oppenheimer Stents Project. Talc thinks that equatorial sunspots means the solar cycle is, quote, coming to an end, which isn't true at all. At solar minimum, we only see sunspots around the equator. So a lack of sunspots at the upper latitudes is an indication that you're at solar minimum. You're approaching solar minimum or sometime around solar minimum. When you see sunspots closer to the poles, that at solar maximum you see high latitude and low latitude sunspots. You see sunspots at all latitudes at solar maximum. So seeing a sunspot around the equator is not at all an indication that the sun is, quote, shutting down or any other nonsense like that. So when there are hundreds of sunspots on the Earth-facing portion of the solar disk, the sun is not shutting down, folks. So that's sort of a little explanation there of the community posts that we've been putting up, because we do market research on the channel, and I hate to see people misled about space weather, astrophysics, heliophysics, cosmology, etc. Now let's talk about systems forming in the Atlantic Ocean, now that we've entered our meteorology segment. We've got 3 systems here in the Atlantic, and they're all looking like they're not really going to amount to much. That would be my forecast based on just looking at this. I haven't really looked at any models for this or anything. I'm just looking at the actual physics here, and look at all the Saharan dust that is mixed into those 3 systems. Those do not look strong. The strongest system looks like it's going to suck in the most dust. What do you see tomorrow? That thing is going to be full of dust, and I don't think that's going to amount to much. So we like to pay attention to all of these things, not just what's going on over here, which is what everybody's going to be talking about all day ad nauseum. And let's take a brief look at it. There's the surface wind scenario for that now making landfall and quickly weakening system. So we'll show you a little bit more on that in a moment here. First, let's look at the wind patterns around the planet. So there are the surface winds of the east. Here are the jet streams of the east. Here are the jet streams of the central world. Surface winds of Europe, Africa, and the Middle East. Surface winds of the Americas. And there are the jet streams. By the way, there's some unfortunate stuff that we've seen in the GFS forecast here. Not good news for places like LA, the Hollywood Hills, etc. We'll show you. So as this hurricane makes landfall, it is weakening quickly. The pressure here all the way up to 983. It's going to be over 1,000 in about 36 hours. However, that's not going to diminish the massive rains that it's going to bring. So the potential energy index here, there is some convective energy available here from the northernmost portions of the Gulf of California. That's not helpful, as it could cause, there is going to be some convection happening there. It's been happening. So if you look at clouds, there's the cloud situation, and it is quite serious. There's like 6 inches of rain coming over the next couple of days. So be prepared. Do not get washed away in floodwaters. It is, it's going to be extreme. And again, LA is now in the crosshairs more than it was. Let's take a look here at clouds and fog. Here is the satellite view for the Americas. And here are these 3 lows in the Atlantic. They are inundated with dust. And here's your weather.gov map, and you're going to see hurricane warnings and tropical storm warnings, heat warnings, and flood warnings all over the U.S. If your location is lit, weather.gov would be a place to get those warnings. We showed you the key. We showed you the full map. Here come some forecasts. And we're starting out with total accumulated precipitation. So check it out. That is a 6-inch rain forecast for areas quite close to LA there. This has been shifting to the west, and that is not a good thing. You can expect mudslides, landslides, extreme flooding. Don't drive across floodwaters. Total accumulated precipitation there over the next 72 hours. That is some massive flooding. Also 5+ inches of rain coming to portions of Nevada. So that should help you be prepared. Next, the 72-hour GFS pressure and precipitation forecast. So again, even though the winds are weakening and the pressure is dropping, the rain is still coming. So rain can do just as much damage as winds. In fact, in some places, rain is capable of doing a lot more damage than winds. Hilly locations, mountains have been known to collapse because of extreme rain. So there you go. There's your pressure and precipitation forecast. Also some heavy weather here coming to southern Texas in the coming days. Next, your jet stream forecast. And this jet stream setup is part of what's allowing that system to move the way it's moving. The jet stream here staying well north of the U.S., and that is allowing that system to move almost due north. Last but not least, temperature anomaly forecast in degrees Celsius. Wow, eastern Nebraska is going to see temperatures here that are like 20 degrees Celsius above normal. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, lightning. It does strike twice. Don't assume it's not going to strike twice at the moment here. Not a lot of lightning strikes in the U.S. over the past 10 hours. Let's check a real-time lightning map. That is lightningmaps.org. So Central and Eastern Europe, they're getting some lightning in the Gulf and off the Atlantic coast. But no terrestrial strikes here at the moment in the U.S. We'll close out with Doppler radar, mainly for the lower 48. Also clouds and fog. And heavy rains already showing up there in California, Nevada, and beyond. There is the clouds and fog 3.9 micrometer infrared radiation map, part of the NASA GOES Interactive Weather Satellite Suite. Here's the 6.19 micrometer infrared radiation map. The water vapor, another part of the NASA GOES Interactive Weather Satellite Suite. And here's your recap. U.S. Doppler radar. It shows vertical motion detected by ground-based systems known as Doppler radar. There is clouds and fog. Actually, let's go back here for a minute. I want to zoom in on that. Heavy rains already striking L.A. 5 inches are in the forecast. There is the clouds and fog scenario. And here is the water vapor scenario. Hey everybody, thanks for tuning into the Smash News Network. Least busted name of news. Congratulations on realizing the channel exists. We're frankly surprised with the pathetic, putrid, disgusting state of censorship. So do yourself a favor and press the subscribe button if you're new, because our thumbnails contain more actual information than entire channel's repertoire of content. See you soon. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.